Hello everyone. Shiny is an amazing technology that allows us to create powerful web applications with a staggering velocity. As a trade-off consequence to this, Shiny deployment can be quite challenging at scale. Thanks to RStudio products, we can deploy Shiny apps with just a few clicks to many users. But sometimes having the right tools is not enough. And we here at Appsilon constantly push the boundaries of what RStudio products are capable of. So if you're interested in Shiny infrastructure and deploying Shiny apps at scale, this is the talk for you. Why you should migrate your existing RStudio products into Kubernetes. Let's ponder this question with our next speaker, Oleksandr, who's an infrastructure engineer here at Appsilon. Hey Olek.
Hello everyone. Let me quickly start the presentation mode. Okay, hello everyone. My name is Oleg. I'm an infrastructure engineer here at Appsilon. So I focus mostly on different kind of deployments, things, security, cloud, containers, all of that kind of stuff. And today we're going to talk with you about how you can migrate your existing RStudio products into Kubernetes. The agenda for today is like this. So I'll talk in today's talk. I'd like to highlight the differences between multiple options for deploying RStudio products from the perspective of an infrastructure engineer or perhaps an IT team. I'll briefly walk you through the pros and cons of running RStudio Connect in a containerized environment. And I'll also try to explain how you can benefit from it in the longer term. We'll also try to answer questions like why Kubernetes specifically, why containers, what problems are solved, what problems are not solved yet with containers. And ultimately, we'll try to find an answer for the question whether it's worth migrating into Kubernetes already today. Okay, so let's compare how RStudio products can be deployed today. So in a traditional approach, for example, when a team needs, let's say, RStudio Connect, a typical scenario would be to have an administrator or an IT team that's responsible for configuration of one or more Connect servers. And this is usually achieved by either manually configuring each server manually, and later probably binding them together in case you are seeking for some sort of high availability setup. But very often, this often comes with some sort of automation in place. And people tend to create their own custom scripts, either using Ansible or Terraform or similar technologies. And the biggest disadvantage of such setup is that this automation usually is very specific to your company environment, but also it can be very error prone and difficult to maintain in the longer term. And what I mean by that is that basically when you commit for some technology and you basically create all this fancy automation around that, in some amount of time, a newcomer comes and joins your company as an IT team member, and it has to learn all this tech stack. It has to basically take over the maintenance of this and so on and so forth. And on the right screen side, you can basically see a simplified diagram how RStudio Connect can be deployed these days by using Amazon Web Services cloud provider. So specifically here, we commit to use a managed service called autoscaling groups just to maintain a finite number of Connect instances so that whenever there's higher load average and people coming to see your Shiny application, it's maintained in high availability setup and basically is available for everyone. We also use and commit for using a managed service called RDS, which is basically providing a database for RStudio Connect, which uses to basically store its own metadata in. And of course, this diagram is very simplified. There is a lot of different other moving pieces around this, which IT team has to maintain, upgrade, and so on and so forth. So a preferred way today to deploy RStudio products would be by using containers. And for those of you who are yet unfamiliar, containers are basically lightweight, portable execution environments. These environments usually wrap server application software in a file system. And this file system includes everything it needs to run, like system dependencies, some kernel headers, everything you need to run a specific application. And containers are usually run with some container runtime. And the most popular container runtime these days happen to be Docker. Maybe some of you are already familiar with. So I've experienced and seen that basically yesterday people had been asking questions how you can containerize your Shiny application, how you can use it with Docker. And Docker itself is really a powerful tool, but when it comes to deploying things in a production-grade manner, you usually get to use some sort of a tool for managing containers on a larger scale. And this brings us to Kubernetes. Kubernetes is just a simple orchestration platform for containers. It's kind of similarly to Docker, de facto the standard these days. So with the growing trend of moving everything into cloud, it's also fair to say that at least every major cloud provider has a managed Kubernetes service. Such service usually takes care of all the underlying infrastructure pieces, like storage or compute instances or some shared storage. And admins, IT teams do not have to maintain this on their own when they rely on some managed service. And rather than that, they can just basically focus on managing the RStudio itself as a product. From an RStudio administrator perspective, Kubernetes can be foreseen and perceived as just regular black box. Just like on the right side of the screen, you can see that all the underlying resources we had to manage before are basically covered by this managed EKS, Amazon Kubernetes service here, for instance. So moving on, why containers? Why Kubernetes? What problems do they solve? And from my own experience, I can say that running RStudio in a containerized environment eliminates multiple issues that a typical administrator of RStudio products has faced before. And these are usually things like reproducibility and isolation. For instance, when you switch to using Kubernetes and containers, you also get to use things that come bundled, like, for instance, you get infrastructure as code approach for free, but also we can discuss things like ability to build your deployment once and basically deploy it anywhere. And last but not least is that there's an important topic around monitoring and scaling, which Kubernetes solves really efficiently. Let's dive deep into each of these separately. So reproducibility and isolation. So this one is pretty straightforward. You as an IT admin or infrastructure engineer have probably found yourself at least once in a scenario where there is a system dependency, and this system dependency has to be updated on each single VM where Connect is running. In automated environments that are managed by some sort of automation like Terraform or Ansible, this is usually less of an issue. But when you update them manually, this often takes out of your control and might eventually break things. So containers themselves enforce you to lock down your execution environments. And they do this in a way that whenever you introduce new changes, like new system dependency, for instance, you have to update your Docker file and include the system dependency explicitly. And that's here's a great example of a system dependency highlighted in red, which you basically lock down within your Docker file, which just stays there for the rest of your Connect deployment. And also, because container images are immutable by definition, this also means that any changes imposed on your Kubernetes cluster have no influence on your deployed content. And what I mean by that if you commit to using such managed Kubernetes services like EKS, for instance, whenever there's some requirement to patch security vulnerability on your VMs, you don't have to worry about this nodes taken down being unavailable and that your Shiny application becomes inaccessible. This is all completely transparent for the end users. And all of this is thanks to how Kubernetes operates, because anytime you want to tear down a specific node, your application will be just rescheduled elsewhere and will be still accessible. Moving on about infrastructure as code, I mentioned. So the sweet part about Kubernetes is that there is sort of a standardized way of deploying things in it. This way encompasses that you don't have to worry about how to pass configuration options like database credentials, for instance, or GitHub tokens, or some sort of authentication required for your email server just to send emails from Connect. You also don't have to worry about how you can tie multiple connects together that you had to figure out before in a traditional approach. And yeah, Kubernetes uses YAML configuration files to describe resources that you want to deploy. And a great example is a simplified way of a Kubernetes manifest on the left side, which is basically describing how you can deploy Nginx inside a Kubernetes environment. But a layer above these files, this pure YAML manifests, is that this layer allows you to treat your deployments as packages. And this layer is basically called a Helm chart. And the greatest feature of RStudio Helm charts is that you don't have to write your own, because apparently RStudio has already done a really great piece of work and done that for you. So these charts from RStudio are already available for public usage. You can see an example values passed to RStudio Helm charts on the right side. You can see how easy it is to configure now what is passed and how RStudio Connect is configured here. So this Helm charts approach and infrastructure as code, overall, it basically means that the complexity of installation and configuration of RStudio products is either reduced to minimum or just eliminated. Build once, deploy anywhere. So container applications usually run on supported container runtimes and orchestration services, such as mentioned earlier, EKS, Amazon Elastic Kubernetes Service. But there's plenty of those. For instance, Azure has its own called AKS, Azure Kubernetes Service. And all of them, all of these managed services, they eliminate the need for you, for the IT team, to install to install and operate your own container orchestration software. So you don't have to maintain your own. And they do this by basically managing and scheduling containers on a scalable cluster of virtual machines. So this is sort of like what you had to maintain before in a traditional approach. And this is done basically by these managed services. This means that in a nutshell, you can just reuse the same Helm charts from RStudio, take almost the same values you've seen before, and have exactly the same RStudio Connect configured and deployed in your cloud provider of choice. And all of this, of course, with very minimum effort from your side. Similarly to Helm charts used to deploy RStudio product themselves, there is also a variety of options on the market right now that have a corresponding Helm chart that can deploy tools which are basically used for monitoring and logging purposes. If in a traditional approach, you most probably had to manually take care of how logs are gathered or how you can gather metrics. You almost probably also had to build some custom observability pipeline as well. With containers, Kubernetes, and infrastructure as code specifically, you get a very rich set of functionalities out of the box. And complementary to monitoring, Kubernetes comes with internal mechanism that basically allow you to transparently scale your applications in different dimensions. And this scaling operation is based on different metrics. These metrics are usually scraped by the monitoring tools I've shown you before. And yeah, so with traditional approach, it usually takes time to scale either horizontally or vertically. But with containers, the scaling piece is almost instantaneous. And thanks to this, nowadays rolling out a new version of RStudio Connect or any other RStudio product can be really accompanied with real zero downtime. For instance, when RStudio releases new version of RStudio Connect, you don't have to worry about your applications being inaccessible because your IT team or infra engineers are performing an upgrade. You can basically commit to something called blue-green deployments, where you just spin up an additional cluster of RStudio Connect, and later you just tear down the old deployment when you are sure that the new one is ready. Okay, so far I've described how reproducible container images can be when it comes to deploying RStudio products themselves. This, however, does not yet cover the reproducibility and isolation of content that's deployed into RStudio Connect. And to make it more clear, let's use the terms that are defined by RStudio documentation. So currently, RStudio Connect runs in a local execution model. The Connect application service and all the published content are executed on the same host. This statement is true for both cases when RStudio Connect is deployed in a traditional approach, like VMs or bare metal servers, but it's also true for containers. And just since recently, RStudio Connect has experimental support for a remote execution model in which environments are basically built and the content is executed directly in the containers. And when using remote execution with Kubernetes, published content is executed in a remote container, and such container is absolutely isolated from the RStudio Connect itself, meaning that such model makes the maintenance of R and Python environments, but also system dependencies a little bit more granular. It effectively allows you to deploy two different Shiny applications that use exactly the same system library, but into different conflicting versions. Okay, so this brings us to the ultimate question I raised during the opening. So is it worth migrating into Kubernetes today? And the short answer is yes, it is. And the biggest advantage and the reason for this is basically this growing trend for using containers. And RStudio is already supporting that. As I've said, there is experimental support for these execution environments, which effectively are very close to what you're trying to achieve by putting your entire application inside a container and making it isolated. All the Kubernetes deployments and all this entire ecosystem, it's really more production grade and better tested in today's deployments. It comes with a lot of nifty features I mentioned before. You can just integrate seamlessly Kubernetes into your existing stack. More and more companies are willing to commit into using Kubernetes than to maintain their own infrastructure using their own build tools. And also, the greatest feature and the reason for switching specifically to Kubernetes is there's official charts which are maintained by RStudio. So there is no bigger advantage of using these charts other than they are officially maintained, produced by the vendor, by RStudio themselves. So no one else is better aware how RStudio Connect can be deployed and managed than the RStudio team. And the last thing is this seamless integration with Kubernetes. What I try to mean by that is that basically you can fully commit and run Kubernetes in containers. Run RStudio Connect in containers in Kubernetes. But when it comes to the day when this experimental support is globally released and available, you don't have to configure anything more from your side on RStudio Connect. If Connect is running already in Kubernetes, it will be able to spawn containers for your specific Shiny applications for your content in the same Kubernetes cluster. So you don't have to worry about that in the future. Okay, I guess this would be almost everything from my side. I know this topic of Kubernetes and all the trends around it is really broad. So we haven't had a chance to do some kind of demo or technical things in here. That's why I prepared some blog posts on our site and highly encourage everyone to take a look. It's a small introductory tutorial how you can basically spin up your local Kubernetes cluster and deploy RStudio Connect with it. Okay, thanks for listening.
Hey, it was a very good talk. This was very technical for me. It's nice to know that we are able to customize the deployment at this level. Uh, how challenging do you think that uh, deploying a Flask or Django app at Kubernetes clusters is when compared to deploying a Shiny app using Kubernetes clusters?
So this is not specifically for Kubernetes, since we cover RStudio Connect here. I don't think you can deploy Django within Connect. I guess it's not possible, at least. But we'll have to reach out to official documentation to see if it's working. But other than that, nothing has changed from the perspective of the regular RStudio Connect user. You still use it the same way. The API does not change. Everything you used to deploy before is going to work here as well, except that this is more scalable and more tweakable. You can basically solve this issue of different system dependencies conflicting with each other when you deploy on the same Connect cluster. Yeah, so hopefully this answers your question.
So based on your experience, how much improvement in scaling does this particular solution obtain? For example, I understand that scaling is very much in line with the application which we are talking about. So what if we deploy Hello Shiny application, just a slider with bar graphs? So how many users can use uh, the Shiny app concurrently?
So it all depends on the RStudio. Like RStudio has been capable of handling concurrent users since ever, right? So right now it's all about like how Connect can be scaled. So for instance, if you really had a lot of users coming to see your content on a single RStudio Connect server, which has been deployed in some garage and you're a single Docker container or in a single VM, so you had no chance to scale this when automatically, of course, based on some sort of metrics. And right now with Kubernetes approach, there is a bunch of tools that allow you to scale your Connect itself across different dimensions. And all of this is based on metrics like, for instance, described by Prometheus and so on and so forth.
Okay, we have one more question. So, Rachel wants to know what are your experiences and the financial differences when hosting your Shiny apps with Kubernetes instead without it. As far as I know, this depends on traffic, and the app is general and does not really pay off for low traffic apps. Can you elaborate on this maybe?
Yes, this is absolutely correct. It does not make any sense to boil the ocean and basically deploy the whole Kubernetes cluster if you just have a single Shiny application up and running, which consumes and requires just 10 users, for instance. So this is more about like enterprise level where you have thousands, if not even more, concurrent users. And as for the costs, definitely it's much more pricey to use managed Kubernetes and maintain all of this afterwards. But this is absolutely fine for enterprise grade companies and when you have that amount of users coming.
Boris wants to know, say we have AKS deployed Shiny app consuming our ML model also deployed via ML ops on AKS. Is it feasible a scenario?
I'm not sure if I understand this question. So do you mean like you deploy your Shiny application just as a plain container inside Kubernetes, or do you use RStudio somewhere in between?
Uh, I'm not sure. I think it means without using RStudio, I guess.
Yeah, I don't know the answer for this question, sadly. Maybe
Okay.
we can reach out to RStudio asking for this. But yeah, this is more related to this talk is more related to RStudio on Kubernetes rather than how you can use any kind of Shiny workloads or MLOps on Azure.
Uh, I think that's all the questions we had. And Boris confirmed that the Shiny app is itself on AKS.
Yeah, so I have an answer for this. We haven't tried that. We haven't ever run a Shiny app directly on AKS because we truly believe the RStudio Connect provides really a great. It's more than just hosting platform. It has a lot of different features people rely on, including built-in authentication or ability for some performance containers delivery, for instance. All of this is already integrated in Connect, and we rely on that. And this talk is basically about how you can scale Connect within Kubernetes rather than the Shiny app within Kubernetes itself without Connect in between.
I think that answers the questions. We don't have any more questions. So thanks for your amazing presentation. It was very technical, and I think it will help all the IT teams and companies where they use RStudio Connect a lot. Yeah. Thank you.
Thanks.